Hi. So, welcome everyone to the session today on Down with Shift Left, why you should be shifting down into the platform. So, let's get started here. The agenda really is going to be talk for a moment about myself. What is Shift Left? The key challenges with the Shift Left methodology, why platform engineering and Shift Down methodologies really were created, the key benefits of a Shift Down approach, as well as a summary. So, about myself, my name's Scott Rosenberg. I'm the lead architect in the CT office at TerraSky. I've been a Kubernetes contributor for over 5 years, a sysadmin for over 10 years. And my passions in life are Torah, which is the Bible, whiskey, and Kubernetes, exactly in that order. And I am a proud platform engineering organization ambassador. So, what is shift left? If we look at the CNCF glossary, shift left is the practice of implementing tests, security, or other development practices early in the software development lifecycle rather than towards the end. Now, if this was the reality, it sounds great. Nothing sounds really bad about this. But shift left in the end is a buzzword with no clear definition. Shift left means something different to every persona in every company. Something about testing, something about infrastructure as code, something about security, something about application deployment, something about observability. The only thing in common is that developers have increased cognitive load, and this is a major challenge. So, why shift left though? If I'm saying that it's such an issue, if we agree that it's an issue, why would we even shift left? And the answer is number one, for early bug detection. The earlier we can detect things by having testing run earlier, security scans running easier, we can find the bugs quicker, which means we'll also solve them quicker. We have improved software quality typically when we move to shift left approaches. We get a faster time to market. We get cost efficiency. It removes IT as the blocker of innovation, right? All of these things are major reasons why the industry went down the shift left approach. But let's take shift left security as an example. And there's a great quote from Kelsey just on this, which is that I think we're asking developers to do too much by shifting everything left, including security. While it should be a collaborative effort, the idea that developers need to become security experts in addition to everything else just isn't sustainable. And this is the major issue with shift left. We're shifting over responsibility to someone that is already overloaded with so much cognitive load, adding in above that security and infrastructure as code and all of these different things just is not sustainable over time. So the challenges with shift left in general are, skill gaps, right? The developer is not an expert in infrastructure. It's not an expert in security. They're not an expert in all these things that we're shifting to them. So we have major skill gaps there. We also have increased initial workload. The developer has to do so much more now just to get started working. There's also a lot of times cultural resistance to things like this, whether it's from the infrastructure teams feeling that things are being taken away from them, or the developer who's getting annoyed that he now has to deal with 35,000 other things when he just wants to create a simple Hello World application. Also, the tooling and integrations is a challenge where a lot of times the tools for security were built with a security operations mindset and security operations persona in mind and don't really fit into the workflow of a developer that well. And balancing speed and quality is always a challenge when it comes to these types of things. And also, the lack of separation of concerns is a major challenge. Security care about security, operations care about operations, developers care about development, and this lack of separation of concerns and mixing everything and mashing it all together is a major challenge. If we take a look at a great, story that, really in my mind sums up what shift left is, it's basically us saying, hey, Mr. Plumber, you're pretty good at installing pipes in the unfinished walls of our new houses. But it's kind of hard to schedule the drywall guy to show up the moment you're done. And sometimes the delay causes schedules to slip. So we're thinking it would be better if you just do the drywall too. And maybe while you're at it, you can add a coat of paint or some wallpaper since you'll be at the wall anyways, right? And that way we won't have to wait for the painters either. And don't worry, you'll still have the same amount of time per job that you had when you were just doing the pipes, and you'll still get paid the same. And that's what we've done to our developers with the whole shift left culture. So, what is shift down? Shifting down to the platform addresses the challenges that shift left was created to solve, but does so in a transparent and seamless way, increasing developer productivity without cognitive overload and with maintaining a clear separation of concerns. So, what does this look like? In shift left, developer scans code using IDE plugins or CLI based scanners. Shift down approach, developer pushes code to Git and code is scanned automatically. Or in the shift left approach, a developer receives a list of all found vulnerabilities in their application and must manually check and research which of the vulnerabilities is exploitable in their application. In a shift down approach, a developer receives an auto generated VEX document showing which vulnerabilities are exploitable in their application at runtime. Right? In a shift left approach, a developer must remember to run security and testing steps early in the SDLC. But in a shift down approach, security and testing is automated in the platform. From a shift left approach, a developer must understand low level cloud constructs to build and maintain cloud infrastructure for their applications via infrastructure as code tooling. In a shift down approach, developers are given a self service portal or an API to consume curated services which hide the complexity of infrastructure concerns, freeing them to focus purely on the code. Few more examples. In a shift left approach, a developer creates Docker files and needs to rebuild images whenever vulnerabilities are flagged. Shift on approach, developer pushes code to Git and images are built automatically. Images are also automatically patched and rebased when vulnerabilities are found in the base OS and system packages. Shift left approach, a developer needs to define resources, requests, and limits on their applications for all environments. Challenge, developers don't know how many resources their application actually needs. By the way, neither do operations teams, but that's a whole nother issue. In a shift down approach, resource management is automated via dedicated tooling which continuously optimizes requests and limits in a policy driven and automated manner. A shift left approach, developers start writing new microservices from scratch and must read internal documentation to figure out how to implement company standards and best practices. From a shift down approach, application bootstrapping is enabled via a templating engine in a self service portal, allowing developers to start from a baseline source code built according to the company's standards. So, what are some good examples of shift down tooling? Kubescape, for example. Kubescape is a great incubating project in the CNCF that automates VEX document generation. So we can have it automatically generate VEX documents for each of our applications that's running in Kubernetes. It's amazing for that. We have tools like Harbor, which does automated image scanning in the registry on push. So we can get that scanning without needing to convolute our developers with additional steps. We can use Sneak, for example, for code scanning in Git with PR generation with security fixes, which is amazing. We can get software templates, for example, in Backstage. Right, Backstage really is the key, and software templates is one of the features. But Backstage, which is central visibility for all elements of the software development lifecycle and runtime information. And from within Backstage, we have our software templates, which allows to create those custom application starters with security and standards integrated into the templates from day zero. We can use tools like Kpack, which utilizes cloud native build packs and is a Kubernetes native build system that allows us to give it source code and it will build a container image following best practices with no need for Docker files or anything of that sort in ways that allow us to also do automatic rebasing of the base image and of system packages when vulnerabilities are found there without the need to recompile our entire application. We can use tools like ScaleOps, which is, in my mind, the best tool out there for automatically fine-tuning resource requests based on real-time data. There are a bunch of tools in this area, and any of them is going to be better than nothing, really, where the idea is let these systems who understand what your actual resource usage is over time, bring them in, and they will automate the fine-tuning of resource requests and limits on your applications in Kubernetes because a developer doesn't know them and a operations team doesn't know them. And when we integrate this into a cluster that's also, for example, using Carpenter, which also fine-tunes and optimizes our node sizes in Kubernetes, we can get the most optimized environment from a resource utilization and cost perspective. A tool like Pixie is also a huge thing here, where Pixie does auto instrumentation and observability for our applications, including profiling and some really amazing things, all using eBPF technologies. Meaning, by doing the auto instrumentation at the eBPF kernel level, we don't even need to shift certain responsibilities to our developers to add certain things into their code so that we can integrate it into our observability platform. It's done from the infra level, but at a really, really powerful and strong level. And Pixie is really an amazing CNCF tool as well. Another great tool in this area for shift down is Crossplane, defining custom APIs and abstractions above any resource or API. We can define an API of a database or of a queue or whatever, and it shouldn't matter to my developer whether this is running on Azure SQL or RDS or a Google SQL or using, cloud native Postgres operator. We can define a custom API and abstract away all of the infrastructure details that don't matter to our developer. Let him only supply what he actually cares about, and give him standardized outputs that he can utilize within his application. This is a really, really powerful concept. So, what are the key takeaways here? Number one, shifting down to the platform enhances security. By having the custom APIs, by abstracting things away, we make things much easier. We add security at early phases in the platform using build packs, using Sneak, using all these tools. We can enhance security in really powerful ways. It lowers cognitive load on developers by only exposing them what they actually care about and letting the platform deal with everything else. It can be implemented in phases. Any one of these projects or projects that are similar will automatically bring value, even if just one is implemented. And the more we implement and the more we move down to this shift down to the platform approach, the more benefit we're going to get. But it's not an all or nothing situation. It easily integrates into existing workflows, which is really powerful as well because we don't need to tear and replace. We can easily incrementally add these things, and it helps with standardization. The second that we move human hands out of the process and as much of it is automated as part of the platform as possible, we get standardization, we get less deviations from the standards as well, which helps us maintain and evolve our platform over time. It can also be much more cost effective and efficient than shifting left or keeping it on the right like it is today in many organizations of the SDLC, because we are not wasting the time of our developers or our operations teams on doing these repetitive tasks. Rather, we are implementing a tool that will do it automatically for us, usually quicker, without wasting human hours. So again, a huge benefit from both cost and efficiency perspectives. So I hope that you enjoyed this. I hope that this was beneficial, and I hope you enjoy the rest of the conference here. And let's all go and shift down to our platforms and build the better platforms for tomorrow.